Hi Chem Peeps. Today we're going to talk about naming acids, and when we talk about naming acids we need to consider that there are two types of acids. The first type of acid, if we look at the top of my page here, are what we call binary acids, and that basically means they contain two elements, of which one of them is hydrogen. So acids begin with hydrogens, and so we have a hydrogen with another element. So when we go to name this, the hydrogen becomes hydro in the name, and we start the name with hydro. Then the element is going to drop its ending, and we're going to add ic to the end, and then of course we add acid also in the name. The other type of acid is what's called an oxyacid. In other words, it's not binary. It's actually hydrogen with a polyatomic ion. So your polyatomic ion chart that you have in your book or your teacher gave you is going to become very important in this naming process, whether we're naming it or we are writing the formula. So the first thing that we need to know is that when we're talking about polyatomic ions, we either have an ate or an ite ending. We're going to drop the ate and add ic, ic, and we're going to drop the ite and add us, which is ous. The hydrogen is understood, so it is not part of the name. And then finally, we're going to put acid on to the end. So below you can see I have some examples. So let's go to the left side. I'm actually going to pull this up, so this is going to be, this is going to be a little bit bigger. And just expand it for our writing purposes, so that you can see a little bit better. Okay, so looking at our examples here, we're going to go to 17. You can see that it is not binary. We have phosphate as part of the compound. So the hydrogen is going to be ignored. So this is an oxyacid, and we're talking about phosphate. So we're going to take the ate ending off, and we're going to add ic. So the name of this is going to be phosphoric acid. Now you're like, where did the OR come from? Well, we kind of go back to phosphorus's name and add that on. You'll get used to doing that. So if we look at 18, we can see it's binary. We have a hydrogen with a chlorine. The chlorine, we're going to drop the ID E ending or INE ending, and we're going to add ic. So and we need to name the hydrogen. So it becomes hydro for the hydrogen, and then chloric instead of chloride or chlorine, and then acid. Okay. The next one you can see is not binary. It has a poly. That poly is sulfate. So we're going to take off the ate ending and add ic. So this is going to become sulfuric. Again, the ur comes from the name sulfur, and then acid. Okay. The next one, we have another poly. So this is an oxy. That is nitrite. So we're going to take the ite ending off, and we're going to add us. So this is going to be nitrous acid. The next one's done for us. It's binary. Iodine, we're going to take the IDE off, and you can see we say iodic acid. Hydroiodic acid. All right, next one. This poly is acetate. This is going to be an oxy. We're going to take the ATE off and put IC. So this is going to be acetic acid. The next one is binary. We have fluorine. We're going to take the INE off and add X. And we do need to add the hydro because it's binary. So it's going to be fluoric, hydrofluoric acid. All right, next one we have an oxy. This is phosphite. And take the IT off, and we're going to say phosphorus acid. Okay, next one. This poly is chlorate. We're going to take the ATE off and add IC. So this is going to be chloric acid. The next one, this is a poly called carbonate. We're going to take, this is an oxy, we're going to take the ATE ending off and add ic. So this is going to be carbonic acid. I'm just going to put ditto there. Okay, the next poly, this is an oxy. This is sulfite. We're going to take the ITE ending off and add us. And acid. Okay, next one. This is actually fluorite, the oxy. I'm going to take the ITE ending off and put us. So this is going to be fluorous acid. And the next one we have NO3, which is nitrate. I'm going to take the ATE off and we're going to add ic. So this is going to be nitric acid. Oops. Okay, and then the last one is binary. So this bromine or bromide is going to become bromic. And so we're going to say hydro, because we have to include the hydrogen, bromic acid. Okay, so that is how we write the name. So let's flip to the other side. I want to change my color here, just to kind of refresh. And I'm going to shrink. I'm going to try to shrink this down. Yep. And I'm going to shrink this one down. And we're going to increase this one. Oops. Okay. So let's go back to writing. All right. So now we're going the opposite way. So if we look at this chloric acid, there's no hydro on here. So this is an oxy. It's an oxy. And chloric, if I take the IC off, I'm going to put 8 back on. So this is going to be chlorate. So if I write this, and I also need my index because I need to know the charge on these polys. This is a -1. So that means I'm only going to need one hydrogen with it because hydrogen has a +1. And then the chlorate formula is ClO3. Acetic acid. So there's no hydro here, so this is an oxy. Acetate is the poly, and it has a -1 charge. That means one hydrogen with the acetate poly. The next one's done for us. Hydro tells me it is binary. Bromic, it comes from bromine. So we're going to add hydrogen with the bromine, and bromine is a -1, so we have HBr. Sulfurous means that it's oxy. So we're going to be talking about, we're going to be talking about the polyatomic ion sulfite. Sulfite has a -2 charge, so this is going to be H2SO3. Chlorus. Chlorus is a poly. It is chlorite. It has a -1 charge, so we're only going to need one hydrogen with the chlorite poly. The next one, hydrochloric, that means it's binary. And so we're going to have one hydrogen with chlorine, and chlorine is a -1, so it's 1:1. Phosphoric, that means this came from the polyphosphorus, or phosphate, sorry. It is oxy, and so this has a -3 charge, so it's going to be H3PO4. Now just reminder here, these poly formulas I have learned, but you can look on your index for polyatomic ions. Okay, nitrous. Nitrous means it comes from nitrite. And nitrate has a -1 charge, so that means one hydrogen with NO2. Hydrofluoric. Hydro means that this is binary. Fluorine's no, it's not FL, sorry. F with a -1 charge, so this is going to be HF, 1:1. Perchloric means that we're going to talk about perchlorate, which is a poly with a -1 charge, so we're going to have one hydrogen with ClO4. Hydroiodic. Hydro means this is binary, so we're going to have a hydrogen paired with iodine, and iodine has a -1 charge, and so it's 1 to 1. Just move this up a little bit so we can see it a little better. Okay, so phosphorus means that we're coming from phosphite, and it has a -3 charge, and so it's going to be H3PO3, and it's oxy. Carbonic means that we are dealing with the polyatomic ion carbonate. Carbonate has a -2 charge, so that means it's going to be H2CO3. So I hope this helps you to write formulas and write names for acids. I'm going to be doing more videos on acids and bases, lots to come. So check back on YouTube and TikTok at Chem's Chem Chats. Leave me a like or a comment, and I'll see you in the next video.